In this video, we are going to maximize or minimize, actually both in this case, the function xy subject to a constraint that x and y have to belong to this ellipse. Okay, so first we are going to find the gradients. So the gradient of f will just be yx, right? And the gradient of g would be 8x and 64 times 2, 128y. Okay, so here you do have to worry about the possibility of one of the variables being 0. So we are going to be careful with that. So we know that y should be some kind of constant times 8x. And we also know that x should be the same constant times 128y. First, let's just look at case number 1. And case number 1 is that both x is not 0 and also y is not 0. And then we're going to see what happens later on if they are. But right now, let's assume they're not. Then we can set up the proportion. So we're going to say y divided by 8x equals x divided by 128y. Okay, so let's cross multiply that. That's going to be 128y squared equals 8x squared. And so that's going to actually allow me to express x squared in terms of y squared. So if I were to divide 128 by 8, that's 16. So x squared is going to be 16y squared. And then we are going to use this information. I'm not going to solve this for x because actually in my constraint, I have x squared. So I am just plugging in this thing into the constraint. 4x squared plus 64y squared equals 256. So let's see if I can solve this for y squared. Okay, so that means it's going to be 4 times 16 plus another 64, and 256 over 128 is 2. So what I got is y squared equals to 2. And then x squared is going to be 16 times y squared. So that's going to be 32. Okay, so then what are my critical points? So here, x, when I solve for x from here, I would take the square root of 32, but actually because the square root property is actually plus minus square root of 32. And same thing is going to happen to y. This is going to be plus minus square root of 2. So actually you got 4 different critical points. Square root of 32, square root of 2, then plus square root of 32 minus square root of 2, and so on. So these are 4 points that are potentially where I'm going to have a max or a min. Now let's go back. So that's one possibility, but we can also look at case 2. Case 2 is either x equals 0 or y equals 0 or possibly both. So I don't know. However, if one of them is equal to 0, either x or y, then our function f of xy will just become 0, right? And I argue that that's not going to be maximum or minimum because actually at these points, there will be one positive value and one negative, and 0 is somewhere in between. So it's not going to be the max or the min. So we do not have to worry about 0 after all. Okay. So we just have to plug in these points into our original function. So we're defining that x times y and plugging in for x square root of 32 and for y square root of 2. And we get 8. Okay, now that's going to be the maximum. Now they're both negative. That's going to be the same thing, also 8, right? So that's not going to give me anything else. But if one of them is positive, the other one is negative, I will get negative 8. Oops, putting that in the wrong place. Should be here. And I think that's it.